Hello everyone, welcome back to my additional mathematics channel. For today's video sharing, I would like to start with a new topic which is integration. For your previous lesson, you have learned differentiation. For this new topic, we are going to focus on integration. Let's get started with the class. Have fun! Today we will focus on new topic which is integration. Before we start with the application of integration, let's go through the concept of the integration. Let me explain to you. From the fx, we do differentiation. So we write d dx fx. We will get f prime x, which is differentiation. From the differentiation, if we integrate the differentiation, we will get back the function, which is actually y, or we call as the curve. Alright, so this is a very important concept, and you must understand the concept and memorize it. For example, let dy dx equal to u, right? Okay, we let dy dx equal to u. And if we write dy is actually u multiplied by dx. Alright? So we have to follow step by step. So if we integrate the u with dx, okay, y is equal to integrate u dx. So in short, differentiation of the function is equal to f prime x. That is a symbol for differentiation. We call it the first derivative. So if we differentiate the function, okay, we will call f prime x dx. So the concept is fx equal to integrate the dy dx, f prime x. Alright, so that is a basic concept. If they give you a differentiation, you just integrate the differentiation, you get the fx or y, or we call as the curve. Alright, so if there is a number in front of the function, let's say the number is a, the a can be any number, example 1, 2, 3, or 1 over 2, and the constant you can just factorize and multiply by the differentiation of the fx. Alright. Okay, so in short, you can write as a multiplied by f prime x. So when we integrate a number a with a f prime x, we will actually can factorize the a and then we integrate the function dx. So that is actually meaning that when there is a constant, the constant you can always factorize and then you don't have to integrate together. Alright? So in short, differentiation of any function we write as f prime x. Okay? So example, fx is y, you differentiate, you get 2x. f prime x is 2x. So if you integrate the f prime x, which actually I say 2x right just now, so you will get, of course, the function which is x squared, because the y is x squared, right? The fx is x squared. So if you integrate the 2x, you will get back x squared plus c. So in short, integrate of any dy dx will give the y, or which is fx. And if we differentiate a number times the function, the number we can actually factorize, alright? And we times with the differentiation f prime x. Okay? So the same thing happen when we integrate. We have to integrate the a f prime x. And we will get back of course, the a fx. Got it? So whatever you differentiate, if you integrate you'll get back your function. Alright, I hope you understand the basic concept of integration is actually reversing process of the differentiation. So many of the students actually cannot memorize this concept. So it actually causes them a big problem when it comes to application. So you have to understand the concept and memorize it. So integrate for any dy dx will produce the y. Okay, in short. Alright, integrate f prime x dx will give you fx. The f prime x is dy dx. Integrate f prime x dx, alright, is actually the same with what you applied just now. Integrate a f prime x dx is actually equal to a fx, and is actually equal to a integrate f prime x dx. So if you look at the symbol, it's a bit confused. So you can always use the maybe y equal to x squared, dy dx equal to 2x. So f prime x, let's say, is 2x is dy dx, right? So if you integrate the 2x, you will get back x squared. X squared is a function fx. Alright, so if you differentiate 2, let's say 2x squared, or 2, you times to the 2. So the constant, you can actually just multiply. So let's say we differentiate 2x squared, of course we get 2 times 2x, right? The 2 is the a actually, in fact, right? So when you integrate back 2 times 2x, we'll get 2x squared. That is the meaning. So in short, can you see there are 2 stars there? You just memorize these 2 stars important concept. Integrate for any dy dx will give you fx, alright? So let's have a look at the example 1. Differentiate. Of course, when you see differentiate, the one given should be y because it's dy dx. So that means the y is 4x squared. Differentiate fx is 4x squared is equal to 8x, right? So if I integrate whatever I differentiate, which is 8x, I will get back, of course, the y, which is 4x squared, right? So the answer is very simple if you understand the concept. So the answer, when you integrate the dy dx, which is 8x, you will get back 4x squared. So differentiate 4x squared is given there, right? Which is 8x, right? So, okay, if we reverse back, we integrate the 8x, we shall get back the function, which is the y. By reverse the differentiation, okay, with the integration of 8x is actually equal to the 4x squared, alright, is equal to the function. This is the function. The function is actually y. You can say y equal to 4x squared, alright. So hence we can conclude that integrate of 8x dx is equal to 4x squared, right? That is the basic concept. Whatever you differentiate, you integrate, you will get back the function, right? So remember that integrate dy dx will give back y. Okay, right? So let's apply to another example. The example is about the coal production from a coal mine is given by K equal to 48,000 T minus 100 T cubed, where K is the mass of coal produced in tons and T is the times in years. Wow, it takes years to produce the tons of coal. Find the rate of production of coal. Okay, dk dt in terms of T. So the first step is we differentiate dk dt 48,000, right? minus 3 times 100 times t, and then the 3 minus 1, which is 2. So the first step, you differentiate. So actually, in fact, this is your dy dx. But we don't have y, we don't have x. What is representing y? Of course, k and t. So if the rate of production of coal is given by dk dt, okay, it was given. And then dk dt, it was given in the question. This question is actually a bit different. They give you dk dt, which is 96,000 minus 600 t squared. So you look at that, dk dt, I actually want to express in terms of the how many times of my dk dt just now. It's actually 2 times, right? It's a is a constant, 2 times. So if you differentiate the dk dt with the 2 times there, so okay, let's find out the k, because we want to find the function which is k. So k is just integrate the 2 times of the 48,000, right, minus the 300 t squared. And of course, if we integrate the differentiation, we will get back the function, right? Okay, so our function just now was given, so we can just copy back the function and times with the 2, right? So we just copy back the function k just now, but we have to times 2 because we have to integrate the one with the 2 times of the dk dt, right? So the function that we got back will be 2 times also. Agree? Now we need to find the rate of production when the times is in the 4th year. So we will substitute the 4 into the function so that we can get the rate of production accordingly in tons in the 4th years. So the answer is 371,200 tons, which is actually a big number. Okay, so that is how we apply integration. Now let's proceed to the next question. So exercise 3.1. Given that differentiate 5x cubed plus 4x is equal to 15x squared plus 4. Find integrate 15x squared plus 4 dx. So it's quite simple, right? Because the answer was given. Number 2, differentiate 8x cubed is equal to 24x squared. Find integrate of 24x squared dx. Is also quite simple because it's direct question. So let's see how to solve. So when you integrate the differentiation, okay, you will get back the y for sure, which is 5x cubed plus 4x. So that's it. Very simple, right? If you understand the concept, it will be very simple. For question number 2, you integrate the dy dx, which is 24x squared. So the answer should be equal to the function which is 8x cubed, right? So we will just copy down. The answer is 8x cubed, alright? So that is how you solve the question involving integration. Is actually reversing process of differentiation. Now let's move on to question number 3. The usage of water at mole A is given by the function, okay, the J is equal to 100 t cubed plus 30 t squared, where J is the volume of water used in liters and T is the time in days. Find the rate of water used at mole A in terms of T. So rate is always dt, dj dt. So we just differentiate, will be 300 t squared plus 2 times 30 will be 60 t, right? So the first step is you differentiate, alright? After you differentiate, you get dj dt, which is 300 t squared plus 60 t. Now, if the rate of usage of the water in mode A changes according to another rate, it's actually how many times? It's 5 times. It's 5 times the original dj dt, right? So we will actually factorize the 5. So you're asking to find the volume used on the second day. So let's actually, we want to find the volume, that means we want the J. So we have to integrate the 5 times 300t squared plus 60t, and after we integrate, for sure the 5 we can actually factorize out, and we just focus on integrate the 300t squared plus 60t. So if we integrate the dj dt, we will get J. So that means we will get 5 times of the J, isn't it? Right. So the answer will be 5 times of the originally J given. So then we will substitute the time, which is 2 seconds, and we will solve it and get the answer for the volume. Okay, volume of the usage of water in mode A in liters. So the answer is 4,600 liters. Alright, so that's the end of the class. Till then, I shall share with you more video sharing in my next coming video lesson. Bye bye and have a nice day.